Welcome to this introduction to the exciting world of irrigation design, brought to you by AgriGrid. AgriGrid has been designing various types of irrigation system for more than 2 decades, and it has built a reputation for solving customers' needs with cost-effective and reliable solutions. At the end of this introductory course, you should have a good understanding of what an irrigation designer does and what sets a good design apart from an average or bad one. I will also provide you with an overview of the other modules that make up the complete Irrigation Designers course. This course is not only intended for irrigation designers, but can be used by farmers, landscapers and engineering students that wish to gain a better understanding of irrigation systems and their related components and parts. As a disclaimer, this course is non-product specific, and any reference to specific products is not meant as an endorsement of the performance or reliability of the product. As a designer, you do build relationships with equipment suppliers, and it will be important to evaluate the products in your market and carefully consider the backup support these equipment manufacturers can provide. What is irrigation design? Let's break it down. Irrigation design is all about planning and building a system that gets water to plants, crops, or landscapes in a smart, efficient, and sustainable way. Think of it as creating a custom network. Pipes, pumps, valves, sprinklers, drip lines and controllers, all working together to deliver water exactly where it's needed, when it's needed, without waste. So, what's the goal? Here's the rundown. Smarter water use. It's about precision, getting the right amount of water to the right spot at the right time. The design considers things like soil type, plant needs, and local climate to cut down on waste. Practical layout. This is where you figure out where to put the gear, sprinklers, drip lines, etc., based on the land's shape, size, and slopes. Tapping the source. You'll tie into a water supply, maybe a well, river, or city line, and make sure the pressure and flow keep everything running smoothly. Sustainability focus. Today's designs lean green, using tricks like drip irrigation or high-tech controllers to save water and lighten the environmental load. Tailored solutions. Whether it's a farm, a garden, or a greenhouse, the system adapts to what you're growing, the growth stage, and even the weather patterns in your area. In short, irrigation design blends engineering know-how with a bit of nature smarts, think hydrology and plant science, to craft a watering system that works. It's practical, it's creative, and it's built to fit real-world needs. Becoming an irrigation designer can be a rewarding career choice for a variety of reasons, blending creativity, technical skill, and a positive impact on the environment and society. Here's why someone might pursue this path. 1. Passion for problem solving. Irrigation design is like solving a puzzle. You figure out how to deliver water efficiently to diverse landscapes, factoring in soil types, plant needs, and terrain. If you enjoy tackling challenges and creating practical solutions, this field offers constant opportunities to innovate. 2. Environmental impact. With water scarcity becoming a global concern, irrigation designers play a key role in conserving resources. By creating systems that reduce waste, like drip irrigation or smart controllers, you contribute to sustainability and help combat drought and climate change effects. 3. Blend of creativity and science. The job combines artistic vision, designing layouts that enhance landscapes, with engineering precision, calculating water pressure, flow rates, and equipment placement. It's ideal for those who love both technical details and creative expression. 4. Growing demand. Agriculture, landscaping, and urban green spaces rely heavily on efficient irrigation. As populations grow and arable land shrinks, skilled irrigation designers are increasingly needed to boost food production and maintain sustainable environments. Job stability and opportunities in this field are strong. 5. Outdoor and hands-on work. If you prefer a career that gets you out of an office, irrigation design often involves site visits, fieldwork, and collaboration with contractors or farmers. You see your plans come to life in real-world settings. 6. Tangible results. There's satisfaction in watching a barren field transform into a thriving crop or a lush garden thanks to your design. Your work directly supports plant growth, food security, and beautification projects. Step 5. Hydraulic design and calculations. This is done to ensure the system delivers water effectively. You will calculate water flow rates and pressure requirements for each zone and determine pipe sizes to avoid pressure loss or over-pressurization. You will also account for elevation changes that affect water flow. During this step, you will also size the pump, if needed, to match the system's demand. Step 6. Component selection. Next, you will choose the right equipment for durability and performance by selecting pipes, e.g., PVC, polyethylene, fittings, and connectors. Pick delivery devices such as sprinklers, drip emitters, based on coverage and water distribution needs. Choose valves, filters, and pressure regulators to protect and control the system. Opt for a controller or timer, manual or smart, for scheduling. Step 7. Drafting the design plan. This is done to create a detailed blueprint for installation and provide the client or end user with a visual representation of your design. Produce a scaled drawing or digital model showing all components and their locations. Also include the specifications of components that has been selected, along with their performance characteristics when used in your design. Add a parts list and installation notes for clarity. Step 8. Cost estimation and budgeting. With a design in hand, it is essential to ensure the design aligns with financial constraints. This can be achieved by estimating costs for materials, labor, and equipment. It often happens that you will have to go back to some of the previous steps and adjust the design if needed to fit the budget without sacrificing efficiency. Step 9. Review and approval. With a financially viable plan, it is time to validate the design before implementation. Check for compliance with local regulations and get feedback from stakeholders such as clients, engineers, or contractors. Revise the plan as necessary to address concerns or optimize performance. Designing a typical irrigation system involves a series of methodical steps to ensure the system meets the needs of the landscape or crops while optimizing water use and efficiency. Here's a breakdown of the key steps involved. Step 1. Site assessment and data collection. The purpose is to understand the area to be irrigated and gather essential information. This can be done by visiting the site to evaluate topography, soil type, and drainage patterns. The area is measured to determine shape and elevations and other physical characteristics like the water source. Water can be supplied from many sources such as a well, channel, river, dam, or municipal supply, and test its flow rate and pressure. Next, you will assess climate conditions, for instance, rainfall, temperature, and evaporation rates. With this information, you can determine the types of plants or crops and their water requirements. Step 2. Define objectives and requirements. Purpose. Establish the goals of the irrigation system. Clarify the purpose such as agriculture, lawn maintenance, or garden enhancement. Then calculate water needs based on plant types, growth stages, and local weather. Set priorities like water conservation, cost efficiency, or automation. Step 3. Select irrigation method. In this step, you will choose the most suitable irrigation technique for the site. Consider options like drip irrigation for precision, sprinklers for broad coverage, or surface irrigation for flat fields. Match the method to site conditions, budget, and water availability. Also factor in sustainability goals. For instance, drip systems reduce waste. Step 4. System layout and planning. This is where the fun and creativity starts. Map out the physical design of the system by sketching a layout showing the placement of pipes, valves, sprinklers, or emitters. Divide the area into zones based on water needs, pressure, or plant types, and plan the routing of main lines from the water source and lateral lines to delivery points. Use tools like CAD software or graph paper for precision. So what can you expect from the rest of this course? The course is broken down into modules, each with a test at the end to ensure you have mastered the content. Even if you are a seasoned designer, follow the modules in sequence. Some later modules will assume you have completed the preceding ones. It will now give you a brief summary of what is covered in each module. Module 1. Orientation. This brief module will familiarize you with the key irrigation terminology you'll encounter throughout the rest of this course. We'll be using metric units of measure as our standard, and where relevant, I'll provide conversion factors to other systems, like imperial units. I can't stress this enough. Always double-check that you're using the correct unit at the right moment. A small mix-up in units could lead to major issues in your irrigation design. Module 2. Soil. In this comprehensive module, we will embark on an in-depth exploration of the fundamental properties, characteristics, and classifications of the soils you will encounter and manage in your irrigation practices. To lay a solid foundation, we will begin by addressing the essential question: what exactly is soil? This will provide you with a clear understanding of soil as a dynamic living system that supports plant growth and sustains agricultural productivity. Next, we will delve into the physical attributes of soil that play a critical role in irrigation and water management. You will be introduced to key concepts such as soil texture, which refers to the relative proportions of sand, silt, and clay particles. Soil structure, which describes how these particles aggregate and form a framework. Infiltration, the process by which water enters the soil. And permeability, the soil's ability to transmit water through its pore spaces. Through practical examples and detailed explanations, we will guide you in assessing a specific soil sample's water-holding capacity, an essential skill for determining how much water the soil can retain for plant use. This section will also include an expanded discussion on soil water quantification, where you'll learn techniques to measure and interpret soil moisture levels, enabling you to optimize irrigation scheduling and efficiency. By the end of this module, you will have a well-rounded understanding of how to evaluate soils, tailor irrigation strategies to specific soil types, and maintain sustainable agricultural systems that balance productivity with environmental stewardship. Module 3. Crop-water relationships. In this module, we will delve into the complex and fascinating relationship between various crops and their water requirements. The initial stage of any agricultural project planning and design process involves a crucial step: determining the precise crop water needs. A plant functions as an organic pump, actively extracting water from the soil reservoir beneath it. However, its role extends far beyond that of a mere pump. Plants are dynamic systems that respond to fluctuations in groundwater tension or an excess of water, demonstrating a remarkable ability to adapt to their surrounding water environment, provided the conditions remain within reasonable limits. Through the process of transpiration, plants absorb water from the soil and release moisture into the atmosphere. This occurs via tiny openings called stomata, where water is exposed to the air and evaporates as water vapor, contributing to the hydrologic cycle. We will also explore the key environmental factors that define an area's climate and directly influence crop water needs. These factors include rainfall patterns, temperature variations, wind speed and direction, humidity levels, and solar radiation, among others. We'll discuss practical methods for collecting and analyzing this data to ensure your planning aligns with the local environmental conditions. Lastly, we will examine the concept of evapotranspiration in detail, a critical process that combines evaporation from the soil surface and transpiration from plants. This phenomenon plays a pivotal role in determining the water needs of crops and has a profound impact on achieving successful crop growth and maximizing yields. By understanding evapotranspiration, you'll gain insights into how to optimize irrigation practices and enhance water use efficiency, ensuring sustainable and productive agricultural outcomes. Module 4. Water. In this module, we'll plunge headfirst into the fascinating world of water, the very essence of life itself. We'll explore a variety of topics, including the science of hydrology, the processes behind precipitation, the key factors that affect runoff, and a concise introduction to hydrological models that help us understand water's behavior in different environments. You'll also get a foundational understanding of dam engineering, where we'll cover the essentials of dam design, the critical safety features that protect these structures, and the operational procedures that keep them functioning effectively. Next, we'll zoom in on water at a microscopic level, examining the impurities that can compromise its quality, categorized into physical, chemical, and organic types. We'll investigate the techniques used to address these contaminants, such as filtration systems and chemical dosing methods, to ensure water is safe and usable. Finally, we'll venture beneath the surface to explore the hidden realm of underground water. This section will introduce you to aquifers, the natural reservoirs beneath the earth, and boreholes, the engineered pathways that tap into these vital resources. Now that you've developed a solid grasp of the natural factors a designer must account for, it's time to shift our focus to the technical and engineering dimensions of irrigation design. Module 5. Pipe Hydraulics. In this module, we'll dive into the intricate relationship between water and pipes, one of the most widely used mediums for transporting water in irrigation systems. You'll explore the principles of hydrostatics, which deals with water at rest, as well as the dynamic science of hydrodynamics, which governs water in motion. We'll introduce you to foundational concepts such as Newton's laws of motion and their application to fluid behavior, alongside key engineering tools like the Bernoulli principle and Reynolds number, which help predict how water flows through systems. You'll also become familiar with essential equations, such as those developed by Hazen-Williams, Darcy-Weisbach, and Lamont, that engineers use to calculate flow, friction, and energy loss in pipelines. Next, we'll examine the various conditions that occur within pipelines, shedding light on concepts like the hydraulic gradient and energy line, which are critical for understanding how water pressure and energy change along a system. These ideas will give you insight into designing efficient and effective irrigation networks. Additionally, this module will cover the practical components of pipeline systems. You'll learn about pipe classifications, which determine their suitability for different pressures and environments, as well as the vital elements integrated into pipelines. These include water control valves for regulating flow, air management devices to prevent pressure issues, and phenomena like vacuums and water hammer, sudden pressure surges that can challenge a system's integrity. By the end, you'll have a comprehensive understanding of how pipe hydraulics underpin successful irrigation design. Module 6. Typical irrigation systems. In this module, you will gain a deeper and more comprehensive understanding of common irrigation systems employed in agricultural and landscaping practices. The content is designed to provide you with a detailed yet concise introduction to 3 primary types of irrigation systems: flood, static, and mobile. You will explore their fundamental characteristics, operational mechanisms, and practical applications. Building on the foundational knowledge acquired from earlier modules, this section will equip you with the analytical tools and insights necessary to evaluate and select the most appropriate irrigation system for specific scenarios, based on factors such as efficiency, suitability, and resource availability. Additionally, this module will delve into key financial and operational considerations that influence irrigation system planning and implementation. You will be introduced to critical concepts such as development capital costs, which encompass the initial investments required to establish an irrigation system, as well as ongoing expenses, including energy consumption, labor requirements, and routine maintenance costs. Understanding these economic aspects will enable you to make informed decisions that balance short-term budgets with long-term sustainability. Furthermore, the module will provide you with a practical set of guidelines to assist in the design and customization of your selected irrigation system. These recommendations will cover essential design principles, best practices, and technical considerations, empowering you to create an effective and efficient irrigation solution tailored to your specific needs and environmental conditions. Modules 8 through 11 will each delve into a distinct category of irrigation system, offering an in-depth exploration of their unique characteristics and applications. These systems include micro-irrigation, sprinkler systems, moving irrigation systems, and flood irrigation. Each module is thoughtfully structured to cover the essential components commonly associated with these systems, equipping you with comprehensive design guidelines and hands-on practical examples to guide you through the process of designing each one effectively. Throughout these modules, we will dedicate time to key topics that enhance your understanding and skills, such as filtration techniques, chemigation practices, automation technologies, and other relevant subjects that play a critical role in irrigation system design and operation. By the conclusion of each module, you will have developed a strong proficiency in designing the respective irrigation system, enabling you to confidently apply your knowledge to real-world scenarios with skill and precision. With a solid grasp of the natural elements, pipe hydraulics, and the various types of irrigation systems, we are now ready to integrate this knowledge and embark on the exciting process of designing our own irrigation system. This next phase will guide you through the essential steps to create a tailored plan that ensures your crops thrive. Module 7. Planning your irrigation system. In this module, we'll equip you with a clear, practical, and systematic approach to gather, analyze, and apply the data necessary for designing an effective irrigation system. We'll dive deeper into the relationships between soil properties, climate conditions, and crop water needs, revisiting these critical factors to establish the performance standards your system must meet to create an optimal growing environment for your crops. You'll learn how to assess these elements with precision and use them to shape your irrigation strategy. We'll also introduce key concepts such as irrigation scheduling, which will help you determine the timing and frequency of water application to maximize efficiency and crop health. Additionally, we'll explore water balance calculations to ensure your system delivers just the right amount of water, neither too little nor too much. To support this, we'll cover the theoretical sizing of pumps and pipelines, giving you the tools to estimate the infrastructure needed to move water effectively across your fields. Once we've defined the performance requirements and you've selected your crop and the most suitable irrigation system, we'll shift our focus to the specifics of different system types. Whether you're considering drip, sprinkler, or surface irrigation, we'll examine how to adapt your plan to the unique characteristics of your chosen system, ensuring it aligns perfectly with your agricultural goals. By the end of this module, you'll have a comprehensive blueprint to bring your irrigation vision to life. Module 13. Pumps and Drive Systems. In the concluding module of this series, we will delve into the fascinating world of pumps and the intricate systems that power them. Our exploration will begin with an overview of a pump's primary function, which is to transfer fluids from one location to another by imparting energy to the fluid. We will then examine the array of pump technologies available, classifying them based on their operating principles, design features, and applications. This classification will encompass positive displacement pumps, such as gear, piston, and diaphragm pumps, as well as dynamic pumps, including centrifugal and axial flow pumps. To equip you with the necessary skills to assess pump performance effectively, we will introduce you to a range of tools and techniques. These will include methods for measuring flow rates, pressure differentials, and power consumption, enabling you to optimize pump selection and system design. Moreover, we will dive into essential concepts that govern pump operation, such as net positive suction head, NPSH, which ensures proper pump priming and prevents cavitation, and the affinity laws. By the time you complete this course, you will have acquired a robust foundation in pump technology and system design. You will possess the confidence and expertise to select the most suitable pumps for specific applications, considering factors such as fluid properties, flow requirements, and system constraints. Furthermore, you will be adept at designing efficient pump layouts, incorporating appropriate fittings and control devices to regulate flow, minimize pressure surges, commonly known as water hammer, and mitigate undesirable effects like turbulence, cavitation, and priming difficulties. Armed with this knowledge, you will be well prepared to tackle real-world pumping challenges and contribute to the development of reliable, high-performance fluid transfer systems. I trust that you've found this introduction to our irrigation design course engaging, and that it has sparked your curiosity about the wealth of knowledge awaiting you on this educational adventure. A seasoned expert once shared with me that anyone can cobble together a system to move water from one spot to another. However, It requires a unique blend of insight and skill to truly grasp the intricacies of the subject and craft a system that operates efficiently and endures for years to come. I'm eager to welcome you to our orientation module, where we'll begin this journey together. In the meantime, please don't forget to hit the like button and subscribe to our channel so you'll be notified as each new module in this course becomes available. Also, please follow the link in the comments for access to this full course. You are also more than welcome to email us at agrigrid@bluehawkaero.space. See you at the start of the Module 1, Orientation.